Welcome to the structure analysis 1. We are going to start with degree of redundancy of beam. In case of continuous beam or statically indeterminate beam, the shear and moment at any point in the beam are readily known once the reaction component are determined. Thus, these beams are statically determinate internally. For beam, dSi is equal to 0. The degree of indeterminacy of beam is therefore equal to its external redundancy. That's why in the case of beam, we only consider ds is equal to dse. As stated earlier, dse is equal to r, capital R minus small r, in which capital R stand for total number of reaction component and capital R small r is equal to condition of equilibrium available. We already studied in mechanics of solid the reaction, support and types of beam. The little glimpse of the reaction component at support are as shown in figure 1.3, which is reaction component at support. This is first and it is fixed beam, sorry, fixed support, which is reacted all sides horizontally, vertically, and moment. In this case, pin support, there is only two moment, horizontal and vertical. For hinge support, similar, there is a two, and roller support, only vertical reaction are reacted. Internal hinge or pin will provide one extra condition of equilibrium. That's why small r plus 1 link will provide two external extra condition. That means small r plus 2. Now member forces are support reaction. For truss, simply supported, roller support, two reaction, only one reaction. For beam, roller support, one reaction, simply supported, two reaction. Space truss, there is n number of support, 1, 2, 3, 4, all are simply supported, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. For fixed, this is not for a support reaction. This is the example of the body's frame structure, also frame structure and the condition of equilibrium. Now we are going to start with this beam. Just ignore the calculation. We can calculate our side. First, in beam, we can show that there is only simply supported beam, simply supported cantilever beam. In this case, there is a support for reaction 1, 2, and 3, and 3, and the equilibrium condition also 3. So beam is determined. Now the second, both sides are simply supported. For simply supported, there is two reaction 1, 2 and 1, 2. That's why 4 and the condition are 3. We can get the one beam is indeterminate to the first degree. For third beam, fixed beam and simply supported beam. So sorry, simply supported support and fixed support. For fixed support, there is three reaction. For Simply support two reactions, 3 and 2, 5, and the condition are 3, second degree of indeterminacy. Similarly, we can show that the now we can go for a difficult beam structure. DS for continuous beam with one fixed and three roller support. For fixed support, 1, 2, 3 reaction. Roller support 1, 1 and 1. There is 3 plus 3, 6 minus 3, which is equilibrium equation. Now, more difficult structure. In this case, this is roller for 1, simply for 2, roller again 1, 1, 2, 3, 4. 4 minus 3, our equilibrium equation, and we also study for pin and any roller, we can provide one extra equation for this. That's why r plus small r plus 1. That's why 1, 1, 2, 3, 4, 4 minus 3 plus 1 is equal to 0. Beam is determinate one extra condition. Summation m is equal to 0 available at point pin. Now we can take ds for this beam. First support simply 2 reaction roller 1 reaction, simply 2 reaction roller 1. We can calculate 1, 2, 3, 4, 5 and 6. 6 equilibrium condition are 3, but we have 2 pins plus 2, 3 plus 5, 2, 5. We can get 1, 2, 3, 4, 5, 6 minus 5 is equal to 1. Beam is indeterminate to the first degree, two extra condition provided by our link. That's why internal roller and pin 2. Okay, the 1, 2, 3 reaction, 4 reaction, 5, 6, 7 reaction. 7 minus 3 plus 2 plus 1, 6 is equal to 1. Now we can skip some examples and you have to try all other example by yourself. In case you have difficulty, let me know. We will solve and go further. Let us start a second topic of degree of redundancy of plane truss. There is a little difference between frame truss and frame. Before we start, dif different, we can introduction about the plane truss. A truss or an articulated structure is composed of link or bar assumed to connected by frictionless pin at the joint and arranged to the area enclosed with the boundaries of the structure is subdivided by the bars into geometrical figure which are usually triangles. If all the member of truss lie in one plane, it is called plane truss. If member of a truss lie in three dimensions, it is called a space truss. In plane truss or space truss, load are applied at the joint only. There is no load in a member. The member of truss are subjected to only axial force. Now we can look at the sorry difference. A truss or an articulated structure is composed of link or straight bars assumed to be connected by frictionless pin at the joint. In the case of frame, a frame is a structure composed by link or straight bar connected at their end by rigid joint. In truss, force are applied only at the joint. In frame, they force apply in member too. Members are subjected to axial force. Members are subjected to axial force, shear force, and moment in case of frame. In case of truss, the member of truss experience deformation in the form of axial compression or tensile in nature. In frame, they have significant deformation in the form of flexural and axial deformation. The members subdivided the structure into geometrical figure, which are usually triangle. In the case of frame, the members are subdivided the structure into geometrical figure, which are usually rectangle. At each joint of a plane truss, two equilibrium equations are available. Summation of S is equal to 0 and summation of V is equal to 0. And if J number of joint are present, two J equations are available. Rest of the topic are discussed in next lecture.